Okay, so now we're between subjects. To do the between subject analysis, it's relatively simple. All you do is one file for each reaction time category. You open the second data file, RT2, and open. Now this is technically not correct on the right way to do the experiment, and you'll see why if I sort by subject ID, sort ascending, each subject is represented 4 times. So if you're comparing just A to A to A to A, you're comparing different subjects. But we're comparing A to TA, where subjects are in both groups. So this is called a within-between design. A little more complicated than we need to know. But you can easily import your data from this, but you have to move the columns around. And if you have trouble with that, please make sure you ask me in class, because I can show you pretty quickly in class how to move the columns around. For this, it's really simple. Also, when you make your graph, your error bar graph, you're going to make a simple summaries of groups of cases. In this case, we have categories. The reaction time task is a category, and the average reaction time is our variable. And then, dun, 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 we see the same graph. We could actually make exactly the same graph on the within subjects by selecting groups of cases. So here's my reaction time task. The analysis that you're going to do is really important. You're going to analyze, and then you're going to compare means and do what's called a one-way ANOVA. We're going to go over how to do ANOVAs in class on Wednesday. So it's really important that you show up. First of all, reaction time task. Second thing is your dependent variable is your average. What this is going to do is this is going to compare the differences between the groups to see if the difference between the groups is greater than will be expected by chance. But we have 4 groups. We have more than 1 degree of freedom. So we have 3 degrees of freedom. So we need to do t-test to find out where the differences are. So we click on post-hoc. Now, depending on what stats teacher you have, they like different corrections. What these corrections do is these corrections take into account the fact of multiple t-tests. So I put my Tukey's t-test there, and it's going to adjust the total alpha level for all the tests to be 0.05. That allows real differences to be found, and it helps maintain your statistical power. Cool, man. Here we go. So we move this up. What you see is that there is a significant effect between groups. It's a very, very strong effect, because the F ratio, we'll find out, is like a t-score, and that the S ratio, if the groups are the same, if the null hypothesis is indeed true, this is close to 1. And it's not. When we look down at the groups, all the groups are significantly different from each other. All the groups are significantly different from each other. And in that particular case, you start to notice, wow, well, it's really not that exciting. But again, it shows you that each one of the groups, the difference between the means, the standard error, and the probability of it occurring. Here's your confidence interval. These set the error bars. And then homogeneous subsets, everything looks good. So that's it. I mean, that's all you have to do for this part of the lab. So it's really a simple thing. It's one graph and one test. Boom, done.